My Life as a Product, from BIM to GTIN. The result of this proof of concept was presented at the international conference Building Smart in Tokyo by Alexander Bjørland from Holte, Halvard Gavlestad from Norsk Byggtjeneste, and Knut Mathisen from GS1. Digitalization of the world's construction industry is speeding up. It will also change today's business models. We all know that. Many countries and organizations are making their own digital roadmaps, and Norway is one of these countries. This roadmap is a strategy for total digitalization of the Norwegian construction and building industry. All large companies in Norway joined in and developed this roadmap together. They developed the slogan, "We will only succeed if we digitize together." The main focus is to maintain a digital twin throughout the building process, from design to facility management. Building smart standards are essential to make this work. How we consider a product depends on what part of the life cycle phase we are looking at. In this proof of concept, we will take a closer look at the part where we select and order a specific product based on the open standards IFC, BSDD and the NEB supply material. The proof of concept is based on an IFC file for the building we are going to build, and the product we are going to focus on is the window marked as green on the left side of the slide. There are only a few properties attached to the window. The properties are overall height, overall width, and thermal transmittance. These are requirements that all have to fit when we search for a window. Based on these properties, we will search the Norwegian product database, filter on values, and select a suitable window. Furthermore, we will order this window and receive details about the delivery status. In order to achieve the goals of this proof of concept, we were reliant on collaborating with several actors and open standards enthusiasts. We use standards developed and maintained by GS1. These are GTIN to identify a unique product and GLN to identify a unique supplier. We also use the industry-owned NEB supply material format to communicate details for the product throughout the ordering process. Norsk Byggtjeneste has done a huge effort to add BSDD properties to the Norwegian product database. We use this to search and filter product based on BSDD properties. Holte has a database with elements containing product and time estimates. We map these elements to the IFC objects to get a rich model with product cost and hour cost for cost calculation. And both Building Smart and Catenda has also contributed with knowledge and the BIMsync viewer. Holte is a software company from Norway with 140 employees. We produce software for the building and construction industry and has been in the business for more than 40 years, and today we have more than 40,000 users on our software. Before we go into further details about the proof of concept, it is important to get a deeper understanding about the information we get from the BIM. There is a challenge today with most IFC files that they contain little or no information at all about the layers in the IFC objects. Usually the IFC wall looks like this, more or less empty. Most often we get the amount of the wall, but the layer sets are empty or incomplete. So how do we get from a generic wall like this to a theoretical wall with layers, products and hour consumptions to produce the wall? Information we need to be able to cost calculate the wall. And how do we get from a theoretical wall to the final build wall? Holte develop and maintain a large database with all the typical walls used in Norway. When we import an IFC file, we have mapped all the walls and objects used in CAD software to the walls in our database. That way, it only takes seconds from we start the import of IFC until we have an almost complete cost calculation, with both a complete list of products and all the hour it takes to build it. Norgeshus demonstrated this at the Building Smart Summit in London. They managed to automate 90% of the cost calculation by using the tool Holte SmartCalc. The database is completely flexible to make your own elements and mapping files. This is a simplified example of an element structure in our database. It shows how an element contains layers and that the layers contain resources like salary and material. It also shows the consumptions of the resources. This means we can automate the cost calculation based on the quantity takeoff from the IFC model. And if we take a closer look at the material, we see that it also contains the GTIN number, which we can use to order the product. In this proof of concept, we will not use the window from our database. We will instead search for the window based on its properties. And now it's time to demonstrate how we can select this window from the BIM, search for a matching window in a product database based on BSDD properties, and select and order the window. Before we start the process, let's take a look at the IFC file. This is the information available on site from a standard BIM that we usually get from actors in Norway. We know that some are better, but today this is often the quality of what we get. Not much to buy a window from. So we start by creating a project. And once the project is in place, we create a calculation based on an IFC file. SmartCalc has predefined templates to connect different CAD tools with Holtest element and cost database. The customer can create custom templates to suit the way they build. And once SmartCalc finishes the job, you can quality assure the import. In the menu bar, you have full control over the objects that are automatically mapped with your favorite element. And you can also make mappings based on IFC space for interior surface. If you are happy with your choices, create the calculation. With a good template in place, it only takes about 30 seconds until you have a 90% finished calculation. What is not included in the calculation are those objects that are not included in the model, such as finance. In SmartCalc, you can now click either in the calculation or in the model to see the elements you are working on. And when we select the window element, it consists of all the items needed to mount the window in the building. The window is still a generic window with basic information from the model. So, we will now replace the generic window with a real product, and we use the properties we have for the product to find the perfect match. Without using any of the properties in the search criteria, we get over 200,000 windows to choose from. By filtering the search with height and width, the results are narrowed down to 65. We add swing direction and get 39 hits. And finally, we add thermal transmittance and get 4 hits. We choose one of the windows and use it in the calculation. Now we have a window with a GTIN number and are ready to order the product. When we are finished with the cost calculation, we want to write the product back to the model. So we upload the file to Catenda's BIMsync to see how the data is represented. After the calculation is done, we are ready to order the materials we need. First, we create a new order. We then add the supplier we want to use. The selected supplier has a GLN number. Finally, we add the delivery details. You can use the calculation to order the material for each building phase. And you can easily split up the ordering based on the progress plan for the project. And now the materials are ready to order. The order will be sent electronically to the supplier, and the ERP system checks and returns order confirmation, all based on open standards. Afterwards, we can view the order status for each product in the order. We get information if a product has been cancelled and replaced with a replacement product. We are also informed if a product gets a different price than we had in the calculation. The standard we are using makes it possible to order product based on BSDD property, and updated information can be saved back to the BIM model. This is an example from Norway. Byggteam is a Norwegian company that built houses similar to the one in the proof of concept. He says it only takes 30 minutes from he receives a BIM until he has ordered all the products. This was something he used to spend days on. This proves that even if this is a relatively small house, he saves lots of money and gets more efficient by using the potential of digitalization. When the goods are ordered origin from an IFC object in a BIM, it gives new opportunities for information flow to the construction site. As the video shows, a lot of information on the BIM object has occurred since the IFC object we started with. We've got all the layers belonging to the item, with the ability to show which product belongs to each layer. And when this is in place, we can show material price, assembly time, and information from the Norwegian building database, such as assembly instructions and much more. In addition, we have a complete overview of the logistic information on all products in relation to whether they are at the site or if ordered yet. If a replacement product is delivered, this information is also available. This information can then update the model so that we will have an as-built digital twin.